Hi, and welcome back to video 13. For a little change of pace here, I wanted to go ahead and test the code out for doing multiple gas blocks at once. So as an initial test, I'm just trying two at once here. So this is the complete procedures from, well, not completely the beginning. I first square up these bars of steel after I get them, and then cut them up into blocks. And then I move on to this step. So I was feeling a little bit cocky, decided to just jump right in, see how it went. Everything went pretty good. That end mill, that roughing end mill I'm using there is getting pretty dull. Reamer worked out fine. Spotting the gas tube holes after I flipped the blocks over and drilling them. Now they're mounted on fixture 1 and just facing off the surface with the 3/8 inch rougher. And then cutting around the bayonet lug profile. The bayonet lug recesses. That 3/8 inch rougher was getting kind of dull too, as was that 3/16 inch end mill. So this still cut fine, but it was really sounding rough. It's about time to let that end mill go. I was kind of excited to try this part out where it's cutting on two gas blocks simultaneously. Worked out great. Finishing worked out great too. My only issue is that it leaves a lot of those long chips in the valleys in between gas blocks. And if you don't blow them out with air or something, then that end mill recuts them and you can really hear them grinding. So I'm real careful to blow those out. So this is with the added spring passes to make sure to minimize the draft angle from top to bottom from end mill deflection. It's now down to about 1/1000th of draft, which is just fine. New operation I added here is engraving the logo on the face. This turned out really well. I decided to just use that 45-degree chamfer mill to do it since I'm already using that tool for chamfering. It's not very deep, but I didn't want it very deep. See if we can get a better shot of it in there. There it is. It had a little bit of raised burrs around the edges, but they came off pretty easy, and it left a nice clean cut. This turned out fine, although I think because that end mill's a little bit worn, they came out, those rail slots came in a little undersized, so I had to go back with a spring pass. I think I'm just going to keep the spring pass because that'll sort of protect against a wearing end mill. Here's that operation where I decided to remove some material right here to make some clearance around that sling swivel socket post that's sticking up, and I kind of do it in 2 passes now to make clearance for that end mill when it comes in to do the side gutting operation. Now this end mill is starting to get dull and damaged and chipped and everything. It's still going strong, but I can definitely tell it's louder and rougher in the cut. Now I accidentally left this engagement, this radial engagement path here at a rapid, so it rammed into the part there at 100 inches a minute and broke my end mill. So let us have a moment of silence for that guy. This is the Lakeshore Carbide fire plug end mill. It's a variable flute, variable helix, roughing end mill with corner chamfers that is stub length. It's aluminum titanium nitride coated. What else can I say? It has a thick core. And this thing, and I was able to reduce the stick out of it. It was with that other end mill was 1.25 inches. This one is 1 inch, so all around it's going to be a much more rigid setup than the previous end mill. So hopefully our dearly departed end mill successor will live up to its reputation. I can already tell the cut sounds quieter. So then after fixing that, I go through there and buzz off that surface. I used to be very paranoid trying to keep all of my cuts in a climb milling condition, but I've been experimenting with just doing back and forth climb and conventional milling as long as the cutter doesn't leave the material. As long as it stays in the material and it's not an interrupted cut, I try to do that because it just seems smoother. Just the brake jib peck on this drill is working out great. The 3/16 inch end mill is starting to get some wear on it, but it's still making these cuts just fine. Even with the chipped flute tips, it's cutting just fine. So I increased the berth of this round over path to 5 thousandths per side, and that seems to have done the trick. There's now no ledge at all. In order to get that, to prevent that bulge on the side walls of this part, I brought in the rotation limiter size a little bit. It was really kind of oversized. So I'm now leaving 3 thousandths of stock material per side. I've also sped up the spindle speed a little bit and slowed down the feed rate a little bit to kind of introduce less deflection. And all those things have solved that issue. There's now no bulge at all on the sidewalls. And the sling socket swivel fits just fine. The next part coming up, I hope you can hear it well. The audio isn't great because I filmed it on camera, but I had a bunch of problems with my fixture plate that was revealed in some of these cuts, and I traced it all back to the fixture plate, and I'll explain that in a minute. These cuts revealed a few misalignment errors, but ultimately I'm very pleased how that turned out, and I consider it a successful test cut.
Alright, so I ran into a problem, and it took a while to figure it out over there on the surface plate, but I found that there's a slight misalignment between these bosses that are the index points and the surface where I actually index off of with my probe. So what I've done here is, even though the top and the bottom are perfectly parallel with one another, these bosses are not quite parallel with the top, which is where I index from. So what I wanted to do was reface this top and have it be perfectly parallel with these bosses. Now I measured the bosses, they're all exactly the same diameter. So I'm indicating off of the top of them, and so what I'm doing is I'm just sweeping across the top of all the bosses with this dial test indicator, and ended up having to put a little shim, I don't know if you can see it, a little shim under there, and I had to adjust it back and forth to get the pivot point just right to where the bosses are perfectly parallel with the axis of motion here. So I kind of just run it right across the surface. Like I indicated off the first one and zeroed it out, and as I go through here, I measured each one, but really I found I only needed to measure this last one, and that one should be zeroed out. I might switch camera angles here to give you a little bit better shot. Alright, stand by. Alright, let's go for a little ride here. So I get the first boss zeroed out, and then I measured all of them through here, but really we're only concerned with the last one. Right on. So now I'm just going to face the top off, so I know the top will be perfectly parallel with the bosses, and then I'm going to flip it around and then face the bottom to make sure that both the top and the bottom are now parallel. I'm just going to take very little off, just enough to get a clean cut right across the surface. Here you can see how the top surface is no longer square with the head. So I zeroed it out on this side. You can see that needle moving down. I measured it to be about 2.5 thousandths off. It's now reading about 2 thousandths off. So that's about right.
Here's the new surface after machining it parallel to the bosses with the base mill. If you look very closely when the direction changes, you can kind of see the backlash in the probe tip, where it kind of shifts back and forth and the needle doesn't move. That's a clue.
By the way, my door had finally fallen off. This was a really stupid way to attach this door, but they basically just drilled and threaded, or drilled and tapped holes right through this Lexan. And it had cracks all over it, but it finally just gave way and fell apart. I was never really happy with this door, the way it swings out. I would much prefer it to slide, either inside the machine, probably outside the machine. Yeah, there's no way to slide it on the inside. There's too much stuff in there. So I might just look into trying to fab up some kind of sliding door system that slides and then maybe butts up against this gasket and this one. Or I might just put some kind of aluminum channel reinforcement on there and work out something. That'd be the easiest thing to do, but we'll see.
I'm just going to show off some of the images while I explain what happened with the fixture plates. I could not figure out why there was about 4 thousandths of misalignment, and partially it was due to the fact that the index point, which is the corner of the plate, wasn't completely perfect with the the first boss, which made all of them off a little bit, but it was only off by 2 thousandths. The other 2 thousandths I found was that the bosses were not machined. They were not machined parallel to the sides of the plates, and this goes for both plates. So I could not figure out what could have caused that. So I had a hunch that it may have been the vise misaligned, because it's exactly what you would expect to see if the vise was out of alignment. So I went back and I took the vise off. I thoroughly cleaned it, make sure there was no chips or anything under it or anything like that. Cleaned it out, got all the chips out of the screw, the lead screw. Put it all back together, put it back on the table, and then I squared it like I normally do using the Haimer 3D taster. Then I took that off and I put the dial test indicator on, and then I checked for squareness, and sure enough, it was off by about 1 thousandths. And my fixture plates are 12 inches long, so that would account for the 2 thousandths discrepancy over the length of the plate. So what this tells me is that the Haimer that I have has too much backlash in it to accurately measure squareness on the vise. So I'm going to use the dial test indicator from now on. So what I had to do is I had to remachine. You saw what I did with the fixture plate 1, just remachining the sides to be parallel to the bosses. Fixture plate 2 is more, it was tricky because there's bosses on both sides. So I squared up the bosses on one side by doing a similar procedure to fixture plate 1, basically squaring the bosses and then milling the surfaces parallel to them on one side. The other side, the only thing I could do was just buzz off the bosses and then mill a new face and do it in such a way that they're perfectly aligned with each other on either side. And after I did that, I took a bunch of measurements, and sure enough, they're right on. So I can finally put that issue to bed and not worry about it anymore. The fixture plates are done and they're square. Although a new issue that I've come across later, which I'll probably detail in a later video, fixture plate 1 is a little bit too thin now in a way, because I do measure some I measure about 1.5 thousandths of up and down deflection from the edges that overhang the vise versus the part that's clamped in the vise, which tells me that it just deflected upwards when I made the cut, and now it's not perfectly flat. But will it make a difference? I'm not sure yet. But at some point I'll need to machine another fixture plate 1 and use thicker material. Thanks for watching, and stay tuned for the next video.